Hi and Assalamualaikum. My name is Nur Nadira binti Azizan.
Hi and Assalamualaikum. My name is Nurjati Sofia binti Nazaruddin.
Hi guys, my name is Nafisa binti Muhammad Dam.
Hello, my name is Noranis Adelina binti Zaibidi.
Next, let's move to the definition of polynomial function. So, what is the polynomial function? Polynomial function are sums of terms consisting of a numerical coefficient multiplied by a unique power of the independent variables. The derivative of a function may be used to determine whether the function is increasing or decreasing on any intervals in its domain. Polynomial function are function of a single independent variable in which that variable can appear more than once raised to any integer power.
The objective is optimizing problem can be reduced finding the largest and smallest value of a function on some interval and determining where the largest or smallest value occurs.
Problem statement. Given the function fx equal 2x cubed plus 3x squared minus 12x minus 2a. Find the interval where fx is increasing or decreasing. Hence, determine the extremum point. B. Find the intervals where fx is concave up or concave down. Hence, determine the inflection point of fx. Sketch the graph of fx by seeing the above information.
For element 1, critical point. Element 2, decreasing and increasing. Element 3, relative extrema or extremum point. Element 4, concavity. Element 5, the last element is inflection point.
Element 1. How to find critical point? Use first derivative test f prime x to find critical point. This step, let f prime x equal to 0. F prime x equal to 6x squared plus 6x minus 12. 0 equal to 6x squared plus 6x minus 12. The value of x that we get, x equal to 1 and x equal to negative 2. Put the value of x, which is 1 and negative 2, to the equation fx equal to 2x cubed plus 3x squared minus 12x minus 2. So we get that the value of f1 equal to negative 9 and f2 equal to 2. Our critical point is 1, negative 9 and negative 2, 2.
So we will look at the element 2, which is we have to find the decreasing and increasing point. So this is we using the table. Okay, use the first derivative to test f prime x. If f prime x is more than 0, so it will increase. Then if f prime x less than 0, so it will be decreased. And one more, if f prime x equal to 0, it will be a stationary point. So in the table, we have the function f prime x equal to 6x squared plus 6x minus 12. So we have to factorize the function to get the value of x, and after we factorize, we get x is equal to negative 2 and x is equal to 1. So the interval will be 3 because we have two value of x. So the first one is the first interval is x less than negative 2. Next is x more than negative 2 and less than 1. And lastly, x is more than 1. So we have to choose any number to be as a test point. So for the first one is we choose x is equal to -3, and after we substitute, we will get the value of f prime x is positive, so the conclusion will be increased. And the next is we choose the test point is as equal to 0, and after we substitute, we will get the negative value, so the conclusion is decreased. And the last one is we choose is x equal to 2, because the interval is x may more than 1, right? So after we substitute, we will get f prime x is equal to positive value, so the conclusion is increased. So interval increasing is that negative infinity until -2, union 1 until infinity, and for the interval decreasing is that -2 until 1.
In element 3, we will discuss about relative extrema or extremum point. So we have to use second derivative to test f double prime x. For this element, you have to know that if f double prime x more than 0, so the extremum point is minimum. While if f double prime x less than 0, so the extremum point is maximum. And if double prime x is equal to 0, so there is no conclusion. As Jaslyn told before, the equation of f prime x equal to 6x power of 2 plus 6x minus 12. So from the equation, we have to differentiate it for the second time. When we differentiate it again, we will get f double prime x equal to 12x plus 6. After that, we need to substitute value of x from critical point into f double prime x. In critical point, x equal to 1 and x equal to -2. When x equal to 1, so we need to substitute 1 into f double prime x. So we will get f double prime 1 equal to 18. While when x equal to -2, f double prime -2 equal to -18. -18 less than 0, so there is maximum point. So when we want to know minimum point and maximum point, we have to substitute value of x into function fx equal to 2x cubed plus 3x squared minus 12x minus 2. So when we substitute f1, we will get -9. So point 1 -9 is minimum. While when we substitute f -2, so we will get 18. So -2, 18 is maximum point.
Element 4. Concavity table. F double prime x equal 12x plus 6. Let f double prime x equals to 0. 0 equal 12x plus 6. Please look at the table carefully. So the answer is interval concave up -1/2 and infinity, while the interval concave down -infinity until -1/2.
Next, to find inflection point, we let f double prime x equal to 0, which means 12x plus 6 equal to 0. When we solve the equation, we will get x equal to -1/2. Then, we substitute x equal to -1/2, where the inflection point occurred for this fx, derived when f double prime x equal to 0 into fx. After we substitute the x value, we will get 9/2. Therefore, we will get the inflection point, which is -1/2, 9/2. In conclusion, when we plot the graph, we can see the maximum point, which is -2, 18. Next, we can see the inflection point, which is -1/2, 9/2. And lastly, we can see the minimum point, which is 1, -9.